23rd, 7SP4. I can use measures of center and measures of variability to compare data. Yesterday we discussed what? Anybody can remember? At least one thing from yesterday, what we did. Good job. We did mean and mainly MAD, but we did do some median. All right, just some quick vocabulary in case you have forgotten any of this. A dot plot displays the graph with dots. We did look at some dot plots on yesterday. A box plot. This is an example of what a box plot looks like if you are unfamiliar with it from 6th grade. It is a graphical display of data in groups or quartiles. It has a 5-number summary of data. Box plot always have these 5 pieces. You have the minimum value or the lowest. You have the maximum value or the highest value. You have the median of the data set. And then you have the lower quartile, which is the median of the lower half. And then you have the upper quartile, which is the median of the upper half. All box plots have those 5 things. All right, a measure of center, as we discussed on yesterday, describes data by identifying a central point. Mean and median are the 2 central points that we have mainly looked at. Mean, we know that's the average of the values. We will add them all up and divide by the total. Then, of course, the median, we know that's the middle value. Place them in order, cross out until we get to the middle. Mode, we didn't spend much time with on yesterday, but today we're going to have a look at. What's the mode? It is the one that appears the most. Any questions about a review of what you should have learned last year? All right. You remember a dot plot and a box plot? You kind of remember? Okay. I'm going to shake your head. All right. Measures of variability. So measures of center tell us about the central point of the data. And then measures of variability, as we discussed yesterday, tell us about the spread. How far are the numbers? All right, and that can be your range, interquartile range, and yesterday we did mean absolute deviation. So the range, we know that's the difference between the minimum and the maximum value, or in other words, we subtract the highest and the lowest. In a quartile range, if you forgot, that's the difference between the upper and the lower quartile in that box plot. So we will subtract those two. Mean absolute deviation, as we learned on yesterday, we will find the mean, make a new list, and then find the mean of the new list. It tells us how far those points are from each other. Any questions about that? All right. A little bit more vocabulary in case you forgot from 6th grade. A cluster is a group of data points that crowd near each other. You can easily pinpoint a cluster because they're right there close together. This one, you can easily see that cluster. All right, and then of course we have skew left and skew right, which you may have forgotten about in 6th grade. Skew left is where most of the data points are clustered near the higher values. When I taught this in 6th grade, I would tell my students they're the opposite. So if it says skew left, that means most of the points are on the right. And if I say skew right, that means most of the points are on the left or the lower end. Then of course I gave you some pictures to look at so you can see. Skew right, most are on the left, and then skew left, most are on the right. And then, of course, there's one last and final detail about data is an outlier. That's one of those points that's far away from all those other points. You can easily notice an outlier. Looking at this graph down here, what would you say is an outlier? What's not near nothing else? These are all together, so that means these over here will be considered an outlier. I'm sorry, that's all right. So your outliers are easily noticeable because they are nowhere near where they need to be. All right. All right, you can find many values from a dot plot. However, the box plot only got mean those 5 things: median, highest and lowest, and of course the upper quartile and the lower quartile. All right, our practicing is in normal position in Schoology. Give you about a second or so to get there. All right, y'all made it. All right, number 1. It reads, each day during the month of September, an inspector at the supercharged battery factory took a random sample of 30 AA batteries from an assembly line. Across at the long life battery factory, their inspector did the same thing. Each inspector placed the batteries in a flashlight and recorded how many hours they lasted. The dots in the dot plot indicate the average life for batteries in each sample. And then it asks us to use these to compare these data. All right, part A told us to describe the center of each battery life distribution. Describes the center. Looking at supercharged, what would you say that center would possibly be? Look at the point. These are my points. So which one most likely is the center of my data? Looking in the blue. Y'all see the blue like I see the blue? Y'all see the shape of the blue? So where is it coming to possibly show what our center is? And what number does that say at the bottom? Log to the Zoom if you need to, 20. All right, so then looking at long life, where about is the center? Good job. So then I will note that. All right, part B said describe the spread of each battery life distribution. Describe the spread. How far apart are those numbers? Okay. Anybody else? All right, look at the shape of it. Look at blue. Where does blue start? 16. Where does it end? Find the range. Because remember that spread is only your range. Tell you how far they are apart. You said how much? 16 for 25. All right, so that's about 9. And then look at long life. What's the highest? 20. What's the lowest? 11. What we gotta get? So what can we say about the spread? Were they the same? Were they different? All right, C then asks us, based on this information, is long life and supercharged batteries cost the same amount? Which brand would you buy? Why are you gonna buy long life? All right, now look at this table. At the bottom it tells us the average life in hours. So if it's on that lower end, will it last the longest? All right, so which battery should we buy? Look at this at the bottom, average life in hours. So that means whichever one lasts the longest, that's the one I want. Out of green or the blue, which one is closer on the right side? So which one do I need to buy? Why the blue? And how do I know it lasts longer? So then I would say, I would buy supercharged because they last long. They are closer to the right side of the graph. Or in other words, you should know they have higher numbers. That's an easy way to determine, okay, they must be the best. Any questions about it? All right, y'all got it? You tapping as you go? Is it still loading? If it is, you may want to get it on a piece of paper. That way, when you go back later, you can easily just put it in. All right, number 2. It said power to go batteries also went out of business because of too much competition from supercharged. A new competitor called High Energy started to make batteries. They tested samples of batteries exactly the same way as supercharged, long life, and power to go. These graphs show how the high energy sample compared to the supercharged sample in the month of April. And they asked, what do the mean and median say about each brand? Mean and median tell you about each brand. Which one can I find the mean of? The dot plots or the box plots? That would be a dot plot, because the dot plot gives us those numbers. So that means the median, that's the one that's found on the box plot. So we will look at that one first because the box plot is there. Median is always your middle value in your box. So what's the median of high energy? Median of supercharged. Drew, someone that can read? See the board? Like, come on now. All right, so then that means we need to find the mean of the dots. So let's look up top. This 19. How many dots do we have above 19? All right, look like about 6. So multiply that by 19. Dot. All right, next we got 20. Look like about 7. Good job. All right, we got 21. Look like about 4. You said 34? 84. All right, we got 22. 4 of those. Good job. we have 23, 3 of those. All right, we got 24, 4 of those. And we have 25, 2 of those. Good job. Now add all those up. All right, and how many total dots do we have? 6, 7, 4, 4, 3, 4, 2. 7, 4, 4, 3, 4, and 2. How much? So then divide that by 30. $21.3. You got the same cord? All right, now let's look at the next one. We got 17. 4 times 18. All right, 19 times 6. Was that the same from above? 114. All right, 20 times 6. All right, 21 times 7. All right, and then 22 times 3. Good job. 23 times 2. And then we got 24. Add all those up. All right. 3, 6, 13, 13, 12. You got 30 dots as well? You said 30? I'm asking you if it's 30. 7 and 12 is what? 17.1. 2. So we found the means of high energy and supercharged, and then we found the median of high energy and supercharged. What does this tell us about each brand? All right, what's the mean of high energy? All right, the mean was 21.3. And what was the median of high energy? The median at the bottom. Okay. So what does that tell us about high energy? What do you know about my mean is 21 and then my median is 21? But I mean, most of my points is pretty much what? At around what number? 21. Now look at supercharged. What's the mean of supercharged? What's the median of supercharged? What does that tell us about the data? Most of the points are around what number? 17 and Samaj happy y'all ain't said not a nothing. I don't know if y'all trying to get somewhere or what. I don't know. Two people been trying to learn something. I'm gonna call the average data life. The average life of high energy batteries. We said it was what? All right, so it was about 21 because it was the same in both. And the average life of supercharged is between what? Good job. All based on what we found to be able to answer those questions about. All right, got a core? Let me know when you see. I'll try to at least squeeze in one more. You were supposed to record another other class because they get further than you all. They talk, participate, we moving on. We ain't worried about it. All right, the box plot shows ages of relevant sample attendees at two different movies. Tell whether the statement applies to movie A or movie B. All right, answer choice A. It says the median age of attendees is greater. Where do we say you can find the median on the box plot? Good job, Julius. Good job. So looking at these medians, who had the greater one? Good job, movie B. It's closer to the right. All right, B said the interquartile range is 9. Remember, we found the interquartile range by subtracting the two other columns. So looking at this piece, what number would you say is that? All right. Look at the lower end, what number would you say it is? I'll go about 15. So what would be the difference? All right, about 10. All right, looking at the bottom, we'll say that's about what number? Yeah, we'll go about 32. And then this is about what? 20. The difference is about what? 12. They said the interquartile range is 9. So I'm thinking one of these numbers is off. That's the closest one, movie A. All right, the ages are more consistent. Consistent means the ages are closer together. I don't have some way over there or some way over there. So out of movie A or movie B, which one would you say the ages are closer together? Why you say movie A? I'll go with movie A. Notice movie B. It jumped way up here to $45 compared to everything else being around 20. In movie A, everything is about between 15 and 25, and then it may get up to about 35. Movie A. All right, the D says the range is greater. How do we find the range? Highest and the lowest. So what would you say the highest of movie A is? That's about what? All right, 36 or 37, and then look at the lowest value. All right, that'll give us about what? Good job. All right, and then we have about 45, and then what's the lowest value? About, let's say about 14 or so. 29. All right, so which one had the greater range? Movie B. Good job. Any questions about it? All right, cool. You can finish getting what you need. I ain't seen your pencil move. I ain't seen you tapping on nothing. Like, how you get your practice going? I don't know either. But being silent, refusing to participate, refusing to at least get answers of what we do, I don't know how else I can help you. Her computer ain't working, but at least she had common sense, take out a piece of paper. She can go back later and at least put her answers in. I don't know what y'all expect from her. We are preparing to move out. As always, don't forget to go back and have a second look. Don't forget to submit. You feel like you ain't gonna have another look at it, I'll go ahead and submit what we got. That way you can at least receive credit on that. You got it, cool? All right. Those of you at home, have a good day.